Let me differentiate flux generating reaction and rate limiting reaction. Many students are having problem in understanding these two. First of all, what is a flux? Flux is the rate of conversion of substrate into product. Okay. If this is an irreversible reaction. Irreversible reactions are usually in biochemistry called as non-equilibrium reaction. We don't use the word irreversible reaction. Instead of that, we use the word non-equilibrium reaction. Okay. If you see reversible reaction, we use the term equilibrium reaction. See this, if this is reversible reaction, we use the term equilibrium reaction. That means the rate of conversion of substrate to product and product to substrate is equal. That is the equilibrium reaction. In a non-equilibrium reaction, okay, if you see the rate of conversion of substrate to product is higher than the rate of conversion of product to substrate. It is not absolute. Okay, that is why we don't use the word irreversible. If we use the word irreversible, you see that it is like 100% irreversible. In biochemistry, there is nothing 100% irreversible. Okay, that is why we use the term non-equilibrium reaction. Clear? So flux or metabolic flux is the rate of turnover of molecules through a metabolic pathway. Okay. Now, with this background, now let us differentiate flux generating and rate limiting reaction. Flux generating reaction is like a elevated express highway. You know, in India there are so many express highways. Yamuna Expressway. Okay, we all know Yamuna Expressway, Delhi to Agra. It is like an elevated expressway. So in expressway, the vehicles are free. Okay, there is no traffic signal. Okay, they can go in a maximum speed. Okay, so that is like flux generating reaction. It converts all the substrate coming into product. Clear? Flux generating enzyme is like an elevated expressway. Okay, whatever substrate come, you can become product. That is what flux generating enzyme is going to say. If you see rate limiting enzyme, it is like a congested traffic, or you can also use like it's like a toll. It's like a toll booth. Okay. Okay. It's like a custom toll or some other toll booth. Okay. What you are seeing, this is the ITO. In Delhi, there is a place ITO signal. Okay. We used to have lot of traffic congestion in ITO signal. People from Bangalore, they know Silk Board Junction and all, they have traffic like this. So rate limiting enzyme is a congested traffic. Okay, it won't allow everyone to become product, and the rate is very, very slow. Clear? Remember this. So with this basic understanding, now let us differentiate flux generation and rate limiting reaction. Both these reactions are non-equilibrium reaction. That means they are essentially irreversible. Clear? So we have already know what is equilibrium reaction and non-equilibrium reaction. Now when you see the Km of the enzyme, so what is Km of the enzyme? Km is the concentration of substrate at half maximal velocity. Okay, this we all know. Okay, if the Km is very high, that means affinity for the substrate is low. Okay, this is the very basic, everyone know. Okay, now if you see for flux generating enzyme, Km of the enzyme is much lower than the substrate of the concentration. Okay, so let us take the example of hexokinase. Km of the hexokinase is just 0.05 millimoles per liter for glucose. Okay, for glucose. Km is unique for substrate. It is not for everything. Okay, for each and every substrate, hexokinase has a Km. For glucose, the Km is 0.05. The ordinary concentration of glucose in our body is 3 to 5 millimoles per liter. So this is way lower than, very much lower than the usual concentration of the substrate. So this means that essentially whatever glucose comes, it will be converted into glucose 6-phosphate by hexokinase. Okay, so hexokinase reaction is a near zero order kinetics. It is like near, it is not fully zero order, it is a near zero order kinetics. Okay, clear? Hexokinase reaction is a near zero order kinetics. It is going to convert whatever the glucose is coming to glucose 6-phosphate, so that now the glucose 6-phosphate will go into the next series of reaction. Okay, let us come to rate limiting reaction. I already told you that rate limiting reaction is like a congested traffic, or it is like a custom toll. Okay, they won't allow all the vehicle in custom tolls, they will stop some vehicles. Okay, so here in rate limiting reaction, the Km is higher than that of the substrate concentration. Okay, so this is very, very important. Phosphofructokinase 1 is the rate limiting reaction of glycolysis. Km of PFK1 is higher. Okay, so this is, you should know. And many people, they ask me why PFK1 is the rate limiting reaction, why not hexokinase? Okay, let me clarify this doubt also. So today I will clarify these two doubts. So if you see, glucose is converted into glucose 6-phosphate, okay, by hexokinase. Okay, then isomerase is there, so we get fructose 6-phosphate, then we have fructose 1,6-bisphosphate. So this is your PFK1. Okay, so this reaction is reversible, this is irreversible, this is irreversible. Okay, otherwise now we use the term non-equilibrium reaction. So now if you see, glucose 6-phosphate can have various other fates. Okay, it can go for HMP shunt. Okay, the major next pathway is your HMP shunt. Okay, glucose 6-phosphate can also be converted into glycogen. Okay, so there is various fate of glucose 6-phosphate. But if you see, fructose 1,6-bisphosphate, it has only one fate, that is your glycolysis. Fructose 1,6-bisphosphate is committed. Okay, so that's why we call this step as committed step. Okay, fructose 1,6-bisphosphate is committed to glycolysis, glucose 6-phosphate is not committed. Okay, clear? Glucose 6-phosphate is not committed to glycolysis. Okay, so I hope you understood the difference between flux generating reaction and rate limiting reaction.